We're going to continue our lessons in circle geometry by talking about chord properties today. And the first thing we need to do is discuss the vocabulary term perpendicular bisector. Well, perpendicular bisector is a line that divides a line segment in half as at right angles to it. And so what it means is perpendicular has to do with 90 degrees. So perpendicular means something is 90 degrees to something else. And bisector, the word term bi means two, and so two equal parts is what that has to do with by perpendicular bisector. So if I have my line segment over here AB, C is the center point, I put that in, and that divides it. If it's center, it means it divides it into two equal parts. So I put little red lines there to show those are equal parts. And if I draw a line that goes through the middle of this thing, so let's just move this over a little bit. Okay, and so here we go. A line that goes through this center and that is 90 degrees to that line segment, so 90 degrees here, okay. That red line, this here, is called the perpendicular, okay, bisector, because it divides that line segment AB into two equal parts, and it is 90 degrees to it. Okay, let's use that information as we go on here then. We're going to talk about that. Now 1, 2, 3, and 4 are very similar ideas. Well, let's talk about them independently here. First one, the perpendicular bisector of a chord passes through the center of the circle. So what it says here, that if I have the middle of the circle, or sorry, middle of the chord, sorry, and say that's the center of my chord, and something like that. And if I draw a line, this is perpendicular bisector, so it has to go at 90 degrees, 90 degrees to that it goes through the middle of the circle. Okay, I'm kind of rough, this is sort of a rough estimate here, but just kind of drawing these in. And so that's true. It does go to the center of the circle. The second point here is the perpendicular bisectors of two. So let's draw another one. Let's sort of say the middle of this one over here. Let's just change color. Let's just make it blue. Okay. So say that's the middle of the chord. Okay. And I'm going to draw a line that's 90 degrees to that chord. So 90 degrees to that chord. And it cuts into two equal parts. That those two bisectors will join or cross right at the center of the circle, and they do. So if I don't know the center of a circle and I draw two of those things, I can find the center of the circle where the bisectors cross. And I can do that third or fourth time. They all cross at the same point in the middle of the circle. Okay, that's 1 and 2. 3 and 4 continue the same idea here a little bit. If a bisector of a chord in a circle passes through the center, so I'm going to bisect this thing, so let's find the middle. So say that's the middle. And it bisects it, so it's got two equal parts here that it divides it into. And if I draw that bisector, so okay, so it goes through the middle of the circle, then that line is 90 degrees to the original line, green line there. Okay, so that's number 4. It says that has to be 90 degrees if it goes through the center. And so that's number 3. And number 4 says if a line passes through the center of the circle and intersects the chord at 90 degrees, so if I do another one, I'm going to draw a line, the center of the circle, and okay, so it goes through the center of the circle, okay, and that's not a very good drawing. Let's just do that one more time. Okay, I'm going to draw through the center of the circle again. Okay, something like that. Okay, that if center of the circle and it intersects a chord at right, if it touches this at 90 degrees, what it says is that these two halves have to be equal. It bisects the chord in two equal parts. Okay, so that's basically one rule, but 4 different ways of looking at it. Now let's go on to the 5th and last one here, and that's the shortest path between the center of a circle and a chord is a line that is perpendicular to the chord. So let's just, what are they talking about here? Well, they're talking about this right here. From the center of the circle, there, that is the shortest distance to that chord is a line that is perpendicular, or 90 degrees. Well, how do you know that? Well, if I draw another line, let's just draw randomly another line from the center of the circle that touches that chord. So if I took and drew another line, starting from the center, going to the chord, there it is right there. Now, what have I just made? I've just made a 90-degree triangle, haven't I? Which side is the hypotenuse of this triangle? Well, the hypotenuse is the opposite side to the 90 degree in a right triangle. Hypotenuse. Okay, and the hypotenuse, we know that the hypotenuse is the longest side of that triangle. So the hypotenuse is the longest side. Longest side. Well, therefore, it can't be the shortest distance from that center to the chord. This one must be the shorter side. In other words, the shortest distance from the center to that chord, which is the green line. Okay, so let's just put that. So this green is the chord, right? It doesn't matter where I draw that line. I can draw it anywhere. I'm going to make a 90-degree triangle, and every time I make it, I'll be drawing a hypotenuse, or the side opposite the 90 degrees. It'll always be. So if I make it say a little bit shorter, I can draw another one right here, and draw it like this, and that's still going to be a hypotenuse. It will still be the longest side of that new, smaller, skinnier 90-degree triangle. Okay, so that's just another rule, and it's got to keep these rules straight. And let's do a couple of examples now. First example, the radius, which is CE here, bisects AB. So bisects it, so let's just put that down, bisect. So that side is equal to that side. CD measures 6, so CD, this part right here, is 6 centimeters. Okay, chord AB, so this part here, from there to there, that length is 16 centimeters. What is the radius of the circle measured to the nearest tenth? Well, what information do I know here? If I know AB is 16, what does it tell me about AD or BD? It tells me those distances, let's just change color here, those distances are both 8. Because they have to add up to give me 16, the total length of that chord. Okay? They want to know the radius of the circle. So I want to know EC. Now the trick in this one is to draw a triangle, so we can use the triangle idea. Now, one thing about it, before we forget here, what is EC? It's a radius, but it's also the perpendicular bisector of AB, because it goes through the center, okay, and divides it in half. Therefore, this is 90 degrees. That angle is 90 degrees. So let's make a 90-degree triangle by joining A and C together. There. And wait a minute. AC, EC equals AC because they're both the radius of that circle. So if I can find AC, I've got the radius of the circle. How do I find that? Well, it's a right triangle there. I've got two sides, and so I can use Pythagoras' theorem. A squared plus B squared equals C squared. Well, what is A? Well, we can call it 8. 8 squared plus 6 squared equals, well, we can call this R for the radius. So let's just replace that with R. And where are we at here? Okay, so this is R squared, because R replaces the C. Let's calculate that then. So I'm going to get 64 plus 36 equals R squared. Add those together and it gives me 100 equals r squared. How do I find r? Well, I find r by taking the square root of both sides. And again, I'm going to switch these. So r equals 10 centimeters. And there it is. There's the answer to that question. Let's do one more example. And it seems a little confusing at first, but as you do examples, it's the same kind of procedure for many of them. This second example, the circular cross-section of a water pipe contains some water. So in other words, the water is here in the pipe. It's laying on the bottom of the pipe, flowing through, whatever, just laying in there. And the horizontal distance from the surface of the water is 34 centimeters. So this distance across here is 34. Okay. The inner diameter of the pipe is 50. I've got that 50 down there. So the pipe is 50 across at the diameter at the middle of it. What is the maximum depth of the nearest centimeter? So the maximum depth means this. Let's just I'm just going to delete the squiggly for the water there for a minute. The maximum depth has to be right in the middle. Has to be right in the middle here. From there, well, okay, there to the bottom. That's the maximum depth. Okay? So we're looking for that. The depth. Okay? Now, if it's the middle, if it's the what do I call it there? If it's the deepest part, that's going to be right in the middle, and it's also going to be, if I draw it straight up here, that's going to be the radius of the circle, the whole part. The red part and the blue part give me the radius of the circle of that line, and the blue part itself gives me the depth. Okay, so let's just go from there. Well, first of all, what does that do? That divides this into two equal parts, which means that's how much? Well, that means this has got to be 17, this has got to be 17. Because it equals 34, the whole thing. Well, what does the 50, how does that help us? Well, the 50 is the diameter. The diameter is the distance across the whole thing. So we know that the diameter equals 2 radiuses. 2 times the radius. Okay? Well, so the radius is just half of that. The radius is 25. So the radius equals 50 divided by 2, which is equal to 25 centimeters. Again, if this is a perpendicular bisector that bisects it, that means it's got to be 90 degrees. So what I do again, I'm going to draw my triangle. So let's just draw that triangle here. And there we go. And that's 90-degree triangle. That distance there is the radius, so that's got to be 25. That's the distance from the center to the outside of the circle. So I want to, now what can I find out? Well, that can help me find out this right here. That distance right there, from the top of the water to up to the center, the center of the circle. And so let's just do that. Let's find that distance, because that's going to help us. So I'm doing a squared plus b squared equals c squared. Okay, this time we'll call a x, so x squared plus 17 squared is the other leg, and the hypotenuse is 25, so that has to be the c. Okay, so let's just a little bit more space. So x squared plus 289 equals 625. And then what I do, I'm going to get x by itself, so I have to get rid of that 289. So I'm going to subtract 289. Okay. And this is going to give me x squared equals 336. When I subtract that, this cancels out. This gives me 336. And Now let's take the square root. Okay, so take square root, and x equals 18.3. Excuse me. Now it does here to the nearest centimeter, so I can round that off. That's about equal to 18 centimeters. I'm round to the nearest centimeter. So this means this is 18. Okay. But one more step here now. I want to find out what x is. Well, I know that the depth, so let's just the depth plus 18 equals the radius, which is 25. So if I subtract 18, I get the depth equals 7 centimeters at the deepest part there. So this part here ends up being 7 centimeters. And that's that question.